Thank you for joining us for the OrCAD X Capture 25.1 walkthrough. This OrCAD X Capture walkthrough will teach you the basics of using OrCAD X Capture for schematic entry by stepping you through the creation of a schematic design. This walkthrough is comprised of step-by-step instructions, videos, and quizzes to teach you how to use OrCAD X to complete your schematics and embed your design intent for a successful PCB design. This includes how to create and place parts, wire schematics, create BOMs, output PDFs, review schematic designs, communicate the information to the PCB, and more. To follow along with the tutorial, download the course materials. Select the Materials tab for this lesson. Click to download the zip file and extract the file to your working directory. This directory contains a smart PDF of the completed design, a completed library of the parts required for this design, and a folder containing PCB footprints and pad stacks. Each lesson from Lesson 2 onward provides a zip file containing a starting design file for that lesson. Select and copy the capture tutorial.olb file. In another window of File Explorer, navigate to the standard OrCAD Capture library location. See Cadence, SPB 25.1, Tools, Capture, Library. Paste the file to this location. You are now ready to begin the course. To follow along with the instructions and videos simultaneously, select the Open a New Window button displayed under the video. In this lesson, we will show you how to start a schematic in OrCAD X Capture 25.1. Open the Start menu and select Cadence OrCAD X and Allegro 25.1, Capture CIS 25.1. Capture opens to the Start page. Here you can view the latest version of the software and the version downloaded on the current machine. Any recently opened designs are shown under Files. Under the Learn tab, view the latest how-tos created by Cadence to get up and running quickly. Select What's New to view the latest videos posted by Cadence of quick tips, new features, and more. Additional links are provided to the Cadence blog, forums, documentation, and support. To create a new project, you can select New Project from the Start page or File, New Project from the menu. The New Project window opens. Enter the name Capture Tutorial and uncheck Use Workspace to save the project locally. Select the ellipsis to open the file browser. Browse to location to save the project and click Select Folder. Click OK to create the project. The new project opens in OrCAD X Capture. The Capture workspace is fully customizable to improve efficiency. The design hierarchy is visible to the side of the schematic. Multiple projects can be opened and toggled between using tabs at the bottom of the Project Manager. The menu bar includes various options to customize and export the design, place objects, create a PCB layout file, customize the interface, and more. Toolbars include commonly used commands such as Save, Load, Zoom, or Find an Object, as well as common schematic commands such as Component and Wire Placement. Toolbars are fully customizable and can be moved throughout the workspace. Individual panels can be floating or docked depending on your preference. The interface can be customized further in the Preferences window. Select Options, Preferences from the menu. Here you can modify settings for colors, grids, zoom sensitivity, selections, miscellaneous features, text, and board simulation. For this example, we will use the light schematic theme and dark application theme. Select the Miscellaneous tab. Confirm that Automatically Reference Placed Parts is checked to ensure parts are automatically annotated when placed on the schematic. Click OK to close the Preferences window. Additional settings can be configured under Options. Select Options, Design Template to open the Design Template window. Here you can select the page size, set the grid display, and enter title block information. Select the Title Block tab. Populate the fields under text as per your company's standard. Adding this information here will automatically populate the title block on any new pages. The design template can be saved with the Save and Load buttons at the bottom of the window. Now let's specify the title block to use. Select the ellipsis for library name under symbol. Browse to the default library location, see Cadence, SPB 25.1, Tools, Capture, Library. Select the CapSim library and click Open. Enter title block 0 for the title block name. Click OK to save the settings and close the window. Rules can be checked in real time while creating the schematic, allowing you to correct issues as you design. To configure which rules are checked in the desired settings, select the design file in the project hierarchy, then select PCB Design Rules Check from the menu. Select On from the Online DRC drop-down menu to enable real-time design rule checks. Select the Rules Setup tab to configure the rules. Check the options for single node nets, duplicate net names, and unconnected pins. Click Apply and close the window. The preferences and settings have now been configured for the schematic design. In this lesson, we will show you how to manage libraries in OrCAD X Capture 25.1. With OrCAD X, you have multiple options for managing parts and libraries, including cloud-based, on-premise, and local libraries. Any combination of these libraries can be used based on your preferences. For the purpose of this walkthrough, we will briefly touch on each library option, starting with cloud-based libraries. OrCAD X provides the ability to manage libraries in the cloud with workspaces. Designers, librarians, and other users can access and manage libraries in the cloud and easily add components from industry-leading vendors regardless of physical location. Cloud libraries can be created for personal use or shared with team members. In OrCAD X Capture, select Place Component from the menu. The Component Explorer tab opens. Here you can link and place components from Ultralibrarian, Schematic, SnapMagic, and other vendors, as well as your personal workspace and shared workspaces you have access to. Select My Workspace. This will provide access to components in your individual cloud library. Components can be added to this workspace manually or from one of the included vendors. Managing libraries in the cloud provides access to a library of components no matter where you're located and allows you to review component information including the manufacturer and manufacturer part number, distributor and price, lead time, symbol and footprint, and more. Now let's move on to on-premise libraries. OrCAD X includes the Component Information System, which provides a link between Capture and your part database. This allows engineering teams to access the company database directly within the schematic design environment. CIS can be accessed directly in the Component Explorer tab by selecting CIS ODBC. The CIS Explorer window opens for you to search for and place a database part. Here you can view the parts available in the database from the category lists in the Explorer panel. To search for a part, select the Query tab and configure the desired property values to search for. Press Enter to search. Components that fit the configured criteria are listed in the table. Here you are able to review parametric information, distributor information, company part status, symbols, footprints, and more. We won't be placing any parts from CIS in this course, so close the CIS Explorer window. Finally, a library can be created and associated with the schematic project to better organize the parts and ensure they remain associated with the project. For the purpose of the walkthrough, we will choose this option as our library management. To create a library, select File, New, Library from the menu. The library opens in the Project Manager. Right-click and select Save As. Browse to the standard library path. C, Cadence, SPV 25.1. Tools, Capture, Library. Save the library as capturetutorial.olb. In this lesson, we will show you how to create new parts and add them to your design library and schematic. OrCAD X Capture includes integrated access to industry-leading sources for parts and component models. However, sometimes parts are not available and need to be created manually. To create a new part, right-click the capturetutorial.olb library and select New Part. Name the part USB Micro B, set the reference prefix to X. If you know the name of the PCB footprint, add it here. For this example, we will set the PCB footprint to USB Micro B. Click OK to open the Part Editor tab. First, we will need to adjust the boundary of the component for the size we need to draw. Click the boundary to display vertices. Click and drag the lower right vertex to resize the boundary box to 7 by 7 units. To create the part body, select Place Rectangle from the menu. Click to start drawing the rectangle over the boundary box and click again to finish. Now let's place the part pins. Select Place Pin from the menu. We'll start with the ground pin. Enter ground for the name and number. Set the shape to short and the type to input. Click OK to place. Click a location on the part boundary to place the pin. To place another pin, press Shift-G to reopen the Place Pin window. Define the pin properties for the USB ID pin and click OK. Click to place on the outline. Press Shift-G again. Define the properties for D+ and click OK. Click to place on the outline. Press Shift-G. Define the properties for D- and click OK. Click to place on the outline. Press Shift-G. Define the properties for VBus and click OK. Click to place on the outline. Press Shift-G. Enter MT1 into the name and number fields. Set the shape to 0 length and the type to bidirectional. Click to place 4 pins on the outline. The number and the pin name and number is automatically incremented. Press Shift-G and set the name and number to P_1. Click to place 2 pins. Right-click and select End Mode. If you do not want the pin names visible, deselect the Pin Name Visible checkbox in the property sheet. Now let's adjust the part labels. Select the value text and click and drag to move it to a new location. To change the text, double-click it. Enter USB-B for the value and press Enter. To save the part, click the X to close the Part tab. A prompt appears to save the changed part. Click Yes. The part was created and added to the project library. For the purpose of this walkthrough, a completed library of the parts required for this design is included in the materials to accelerate the part creation process. Let's add the completed library into the project. In a project hierarchy, right-click Library and select Add File. The file browser opens the default library folder. Select the provided library and click Open. Right-click the library we created and select Cut. This completes the part creation lesson. In this lesson, we will show you how to search for parts and place them in your schematic. OrCAD X Capture includes multiple options for component placement sources, including common symbols, common components, project libraries, cloud or on-premise databases, and online repositories. Let's place the title block first. Select Place Title Block from the menu. The Place Title Block window opens. Select Add Library to add the title block library. Browse to the default library location, see Cadence SPV 25.1 Tools Capture Library. Default title blocks are included in the CapSim library. Select the CapSim library and click Open. Select Title Block 0 and click OK. Click to place the title block in the lower right corner of the schematic. The title block information is already populated as defined previously in the walkthrough in the Options window. Right-click and select End Mode. Next, we'll place parts from the project library. This library includes the main elements in the design, which should be placed in the schematic first. Select Place Part from the menu or press P on the keyboard. Select Capture Tutorial Library from the Libraries list. Select the Pick 32 part from the part list and click the Place Part button. Click to place the part in the center of the schematic, then right-click and select End Mode. Follow the same procedure to place the connectors and crystal on the board using the provided PDF of the design for reference. To rotate a part during placement, press R on the keyboard or right-click and select Rotate. Place modem JP1, crystal Y1, USB connector X1, and header JP2. When finished, right-click and select End Mode. Now let's place common parts from a library included with OrCAD X Capture. To add a library to the design, click the plus sign in the Place Part panel to expand Search for Part. Verify that the search path is set to the default Capture Library folder. See Cadence SPB 25.1 Tools Capture Library. Enter Cap into the Search For field and click the Part Search icon. This will search for all parts with Cap in the name and libraries in the specified search path. Select the discrete library labeled as Cap Discrete.olb. Click Add. The library has been added to the project and can now be searched in the Parts window. Select Cap NP to place a non-polarized capacitor. Double-click the part listing or click the Place Part icon. Click to place the capacitors according to the provided PDF. The reference designators are automatically annotated. Right-click and select End Mode when finished. Next, we'll place the resistors. Enter resistor into the top search field. Results are listed automatically. Double-click resistor to attach the part to your cursor. Click to place the resistors according to the PDF. Right-click and select End Mode. Enter LED into the search field and double-click the LED listing. Click to place the LED according to the PDF, then right-click and select End Mode. Now let's place a component from integrated access to industry-leading sources. The Component Explorer provides a centralized location to search and place parts from PSpice libraries, UltraLibrarian, Schematic, and SnapMagic parts. Select Place Component from the menu to open the Component Explorer. Select the UltraLibrarian category from the Categories sidebar. Log in by entering your UltraLibrarian credentials and click OK. Enter LT1965EM into the search bar and press Enter. The unified search results will show the manufacturer, part number, description, and availability of the symbol, footprint, and 3D model. Select the part to view additional information in the sidebar. Right-click and select Place to download the part and attach it to your cursor. Click to place the part in the schematic. Right-click and select End Mode. The symbol, 3D model, and PCB footprint are downloaded and automatically added to the design cache. To edit the part symbol, select the part, then right-click and select Edit Part. Click and drag to rearrange the pins such that the grounds are on the bottom, the output pins are on the right, and the input pins are on the left. Close the Part Editor tab. A prompt will appear to update only the current part instance or all instances in the design. Select Update All and answer Yes to any prompts that follow. With the components placed, let's place power and ground connections. Select Place Ground from the menu. Select Ground and click OK. Click to place the ground symbols according to the provided schematic. For this example, there should be a total of 10 ground symbols. To place power symbols, select Place Power from the menu. Select the CapSym library and choose VCC from the symbol list. Click OK. Click to place the power connections according to the provided schematic, then right-click and select End Mode. There should be 3 power connections in this design. If a component database is configured, components can be placed directly from the database into the schematic. To do this, select the Component Explorer tab, then choose CIS ODBC. Select the Query tab in the Explorer window to search for a part. A query table opens. In the first row of the table, set the search criteria as needed. For this example, we will set the property to value, the comparison to equals, and the value to 56,000. Press Enter. All 56 kilo-ohm resistors in the part database are listed in the table below. Each listing has a schematic symbol, PCB footprint, status, and more useful information. To place a database part, right-click a listing and select Place Database Part. From here, you can click and place the component in the schematic as needed. For the purpose of this demonstration, no other components are required, so press Escape on the keyboard to end placement mode. If a cloud-based component database is configured, components can be placed directly from the cloud-based database into the schematic. Select the Component Explorer tab, then select the desired workspace. The workspace parts are listed. If the list is long, browse through the file structure, enter the name of the desired part, or enter a search parameter such as the value into the search panel and press Enter. Review the returned results and additional component information. To place the desired part, right-click and select Place. From here, you can click and place the component in the schematic as needed. For the purpose of this demonstration, no other components are required, so press Escape to end placement mode. This completes the lesson on placing components in the schematic. In this lesson, we will show you how to connect components in the schematic in OrCAD X Capture 25.1. Nets can be connected manually, automatically, or through buses and net aliases. Let's start by drawing wires automatically between the crystal, USB connector, and IC. Select Place Auto Wire 2 points from the menu to activate the auto wire mode. Click one of the pins on line 1. A guideline is attached to your cursor. Click the corresponding pin on IC1 to draw a wire. Repeat this process for the other pin on Y1 and pins VBus, D-, and D+ on USB connector X1. The auto wire feature can be used to quickly and easily make connections between components. Press Escape on the keyboard to end the auto wiring mode. Now let's place wires manually. Select Place Wire from the menu or press W on the keyboard. Click each connection to add a wire and click again to finish. Wire the schematic as per the provided PDF file. Click and drag to adjust components or wires as needed for optimal spacing. To copy and paste wires, use Ctrl-C and Ctrl-V on the keyboard. On components JP1, JP2, and IC1, draw short wires to connect to buses and net aliases. To repeatedly place a wire, press F4 on the keyboard. Pins 4 and 5 of JP2 will be automatically connected to a bus, so do not add short wires to those pins. When finished, press Escape on the keyboard. Now let's place a bus on the schematic canvas. Select Place Bus from the menu or press B on the keyboard. Click to start drawing the bus and click again to finish. Bus wires are graphically thicker than regular wires, as the bus wires are the multi-bit wires used to bundle single-bit wires together. Press Escape on the keyboard when finished. To connect wires to buses, bus entries need to be added. This can be completed manually or automatically. Select Place Bus Entry from the menu. Click to place the bus entries for the IC on pins 17 and 18. To place bus entries automatically, select Place Auto Wire Connect to Bus from the menu. Select pin 5, then pin 4 on JP2. Click the bus to connect the pins. The Enter Net Names window opens. This bus has sequential net, so it will enter the name prog bracket 0-1 end bracket and click OK. This will automatically name the nets connected on JP2 sequentially. Lastly, we need to place no connects to indicate pins that are deliberately left unconnected. Select Place No Connect from the menu or press X on the keyboard. Click to place no connects on the unused pins. When finished, right-click and select End Mode. At this point in the walkthrough, some short pins are left unconnected. These connections will be completed in the next lesson using net aliases. This completes the wiring lesson. In this lesson, we will show you how to create and place net aliases in a schematic in OrCAD X Capture 25.1. Net aliases are text labels that indicate the name of the net. Net aliases can be used to communicate design intent and connect schematic wires electrically. To place a net alias, select Place Net Alias from the menu or press N on the keyboard. Let's start by placing the alias for VBus. Enter VBus and click OK. Click to place the alias on the input for the LT1965 and the VBus pin on the USB connector. By adding the same net alias to these two wires, they don't need to be physically connected in the schematic to be electrically connected. Using net aliases in this way can improve readability of the schematic. To change the alias, right-click and select Edit Properties or press N on the keyboard. Let's place the 3.3 volt net alias next. Enter 3.3 volts and click OK. Click to place the alias at the output of the LT1965. The online DRC window can be used to verify whether connections have been made through net aliases. Several of the violations listed in the online DRC panel concern a net having fewer than 2 connections. Double-click one of these violations to view the associated net. This will cross-probe between the violation and the schematic to easily identify the error. The highlighted wire has no connection and no net alias. To fix this, select Place Net Alias from the menu or press N on the keyboard. Enter the appropriate name as per the provided PDF and click OK. Click to place the alias. The violation was cleared from the online DRC panel as the connection was completed. Continue placing net aliases as shown in the provided PDF. DRC violations are cleared as aliases are placed. If necessary, click and drag to extend wires to make the aliases more readable. Nets with a number at the end of the name will be incremented every time you place the net alias. To rotate a net alias, press R on the keyboard. Net aliases can also be moved and rotated after they are placed on the schematic. When finished, right-click and select End Mode. Net aliases can similarly be placed on buses. Press N on the keyboard to activate the net alias window. Enter prog bracket 0-1 end bracket for the alias name and click OK. Click to place the alias on the bus, then right-click and select End Mode. The online DRC panel now shows that the violations concerning nets with fewer than 2 connections have been cleared. This completes the net alias lesson. In this lesson, we will show you how to add component information in OrCAD X Capture 25.1. With components placed and wired, part information such as component values and PCB footprints can be defined to ensure clear design intent. If components were added through included sources such as UltraLibrarian, this information is automatically populated. To define some of the voltage values, we will use the advanced Find and Replace functionality. This allows designers to quickly find and replace information defined in the schematic. Select Edit, Replace from the menu to open the panel. Enter VCC into the Objects field and select Find. The Find Results tab opens automatically. Select Power Symbols to view the list of fitting symbols. The 3 VCC power connections are listed. To change the connection labels to the required voltages, select the Replace tab again. Select the plus sign in the Find Properties table to add a property. Select Name from the Property dropdown and enter VCC into the Value field. Select the plus sign in the Replace Properties table. Select Name from the Property dropdown and enter 3.3 volts into the Value field. This will replace all instances of the VCC name with 3.3 volts. Click Replace. The power pins are changed to 3.3 volts, which connects them to the existing 3.3 volt nets. Voltage nets can also be assigned during the placement of power and ground pins. To do this, before placing the pin, right-click and select Edit Properties. Add the value of VCC and click OK. The connection will be placed with the correct value. Now let's set the values of placed components, such as capacitors and resistors. Multiple components can be assigned a value through the Property Editor tab. Hold Ctrl and select the row of parallel capacitors. Right-click and select Edit Properties. The Property Editor tab opens, listing the properties of all selected components. Select the Value row, then right-click and select Edit. Enter 0.1 microfarads and click OK. Close the Property Editor tab. The capacitor values have been updated. Let's set the values for the other capacitors. Hold Ctrl and select capacitors C2, C3, and C9. Right-click and select Edit Properties. Select the Value row, then right-click and select Edit. Enter a value of 10 microfarads and click OK. Close the Property Editor tab. Values can be set from the schematic as well. Double-click the value of capacitor C1 to change it. Enter 100 microfarads for the value. Here you can also choose whether to display just the value parameter, or both. Click OK. Hold Ctrl and select resistors R1 and R2, then right-click and select Edit Properties. Double-click the value cell for R1 and enter a value of 150. Enter a value of 56K for R2. Close the Property Editor tab. Double-click the value for Crystal Y1, enter a value of 8 MHz, and click OK. Display properties such as color can be configured for each value as well. Double-click the value for LED D1. Select green from the color drop-down menu in the Display Properties window and click OK. The color of the value has been changed to green. Now let's assign footprints. You can bulk edit component properties with the Property Editor tab as well. In the project hierarchy, select Page 1. Right-click and select Edit Object Properties. This will display the properties for all components placed on page 1 of the schematic. Footprints have not been assigned for capacitors, resistors, or the LED. If the footprint name is unknown, open OrCAD X PCB Designer. Select Place Components manually from the menu. Select the Advanced Settings tab and check Library. Return to the Placement List tab and select Package Symbols from the drop-down menu. To search for footprints with 0402 in the name, enter *0402* and press Enter. This will return any footprint with 0402 in the name. Check the box next to the name to preview the footprint. Back in Capture, enter 1210 into the cell on the PCB footprint row for C1 to assign the footprint. Enter 0402 cap into the cell on the PCB footprint row under C2. Click and drag the marker to extend the footprint to C9. Enter LED LNJ into the cell on the PCB footprint row under D1 to assign the footprint to the LED. Enter 0402 res into the cells for R1 and R2 to assign the footprint to both. Close the Property Editor tab. To verify the footprint assignment, right-click and select Show Footprint. The Footprint Viewer opens, showing the assigned footprint. This completes the lesson on adding part information. In this lesson, we will show you how to annotate your design. Annotating the design will assign unique identifiers or reference designators to each component, which will help throughout layout, assembly, documentation, and more. There are multiple ways to annotate the design in OrCAD X Capture. During component placement, we have the components automatically annotating. To improve readability, let's run an unconditional reference update, which will re-annotate all the components. Select Tools, Annotate from the menu. Under Action, select Unconditional Reference Update. This will annotate all components in the design, ignoring ones that have been assigned already, either manually or automatically. Under Mode, select Update Instances. Additional options are available to annotate the entire design or selection, annotate from left to right or top to bottom, and more. Click OK to run the annotation. You may be prompted that running the annotation will clear the undo cache. Click Yes to proceed and click OK. All part references have been updated from left to right. To reset part references to question marks, select Tools, Annotate from the menu again. Under Action, select Reset Part References to question marks. This will reset all reference designators. Click OK to run the annotation. Click Yes and OK when prompted. The part references have been reset to question marks. Now let's change a reference designator manually. Double-click reference designator D1 associated with the LED. Enter main power for the value and click OK. The reference designator is now underlined, indicating that it has been changed by the user. To update reference annotation and keep user-defined references, incremental reference updates are used. Select Tools, Annotate from the menu. Under Action, select Incremental Reference Update. Click OK to run the annotation. View the schematic. The main power annotation remains the same, but all other components have been re-annotated. This completes the lesson on annotating the schematic. In this lesson, we will show you how to define differential pairs manually and automatically. Differential pairs are used for effective noise cancellation and a robust signal path. Differential pair traces are routed together and specific rules can be defined for the PCB layout, including primary gap, neck gap, and more. To define differential pairs in the schematic, select the design file in the project hierarchy. Select Tools, Create Differential Pair from the menu. The Create Differential Pair window opens. Select Net D+ from the Net list and select the arrow to move the net to the selections list. Select Net D- and select the arrow to move the net. Enter DPD into the diff pair name field. Click Create to create the differential pair. By defining a differential pair, the nets of the differential pair will be routed together in the PCB. For a typical design, you would use either manual or automatic definition. For the purposes of this tutorial, select Delete to clear the differential pair definition. Select Auto Setup to open the automatic setup window. Enter DP into the prefix field. Enter a plus sign into the positive filter field and a minus sign into the negative filter field. Click the diff pair window to generate the differential pair. Click Create to create the differential pair. Click Close to close the automatic setup window and close again to close the Create differential pair window. This completes the lesson for differential pairs. In this lesson, we will show you how to perform a design rule check to generate a report listing any violations. A design rule check identifies problems such as unconnected pins, unconnected nets, pin type conflicts, and more. To run a design rule check, first select the design file in the project hierarchy, then select PCB Design Rules Check from the menu. In the Options tab, under Batch DRC, select Run on Design from the DRC Action dropdown. Select Instances from the Properties dropdown. Select Create DRC Markers from the Warning dropdown. This will create visual markers on the schematic canvas to indicate errors. Select Do Not Preserve from the Wave DRC dropdown. This will clear any previously waived DRC errors. Select DRC Window from the Show DRC Outputs dropdown. This will show the error list in the dedicated error panel as opposed to a separate report window. Select the ellipsis for report to open the file browser. Browse for a location to save the report. Name the report and click Open. Select the Rules Setup tab. Here you can select which electrical and physical rules to check in the design. Custom rules can also be assigned. Leave the default settings and select the Report Setup tab. Here you can select which electrical and physical items are included in the report. Leave the default settings and select the ERC Matrix tab. This is used to test connections between pins, hierarchical blocks, and hierarchical ports. Define a pin combination by toggling between valid, W for warning, and E for error. Leave the default settings and select the Exception Setup tab. Here you can define rules you want excluded from the DRC by selecting the Add New button. Leave the default settings and select Run to generate the DRC report. Click Yes when prompted. When the check finishes, if prompted to open the DRC report in the system log, click No to view the errors in the canvas. Each marker indicates a problem area. Select the DRCs tab at the bottom of the window to open the DRCs panel. Double-click one of the arrows to highlight the affected part, net, or pin in the schematic. Double-click the marker for more information on the warning. Reviewing the warnings, all are OK for this design. To waive a DRC, right-click the marker and select Waive DRC. The marker disappears, indicating that the error has been waived. The DRC report can also be viewed outside of Capture. Open File Explorer and browse to the directory where the report was saved. Open the file in a text editor such as Notepad. DRC violations are listed by schematic and type of rule. The errors and warnings listed here are acceptable and can be ignored for this design, so let's delete the DRC markers from the schematic canvas. Back in Capture, select the design file in the project hierarchy. Select PCB Design Rules Check from the menu. In the Options tab, select Delete DRC Markers from the DRC Action dropdown. Click Run. The DRC markers have been removed, but the error report remains unchanged. This completes a lesson on design rule checks in OrCAD X Capture 25.1. In this lesson, we will show you how to create a bill of materials. Several options for creating a bill of materials are available in Capture, including creating a custom BOM or leveraging CIS features to create a zero-touch BOM and BOM templates. Before we create a bill of materials, we need to define the manufacturer and part number for each component. Right-click in the schematic and choose Selection Filter or press Ctrl-I on the keyboard. Select Clear All and check the box for parts. Click OK. Click and drag to select the entire schematic. Only the parts will be selected. Right-click any of the selected components and select Edit Properties to open the Property Editor tab. In the cell for C1 in the manufacturer name row, enter the name of the manufacturer. Click and drag the corner of the cell to extend the name to C2, C3, and C4. In the cell for C5, enter the name of the manufacturer. Click and drag the corner of the cell to extend the name to the remaining capacitors. The Property Editor tab can also be used to define part numbers. Enter the part number into the cell for C5 in the manufacturer part number row. Click and drag the corner of the cell to extend the part number to the remaining capacitors. To assign these properties to multiple parts quickly, let's use a spreadsheet. Open the provided file, Capture Tutorial Manufacturer.csv, in a spreadsheet viewer such as Microsoft Excel or LibreOffice Calc. Hold Shift and select the entire table. Press Ctrl-C on the keyboard to copy. Back in Capture, click and drag to select all manufacturer name and manufacturer part number cells in the property table. Press Ctrl-V on the keyboard to paste. All manufacturer names and manufacturer part numbers are assigned. Let's add the vendor name next. Click New Property to open the New Property window. Enter Vendor for the property name and click OK to create the property row. Select the new row. Right-click and select Edit. Enter DigiKey for the vendor value and click OK. Click Apply to apply the changes and close the Property Editor tab. Now let's generate a bill of materials. Select the design file in the project hierarchy. Select Tools, Bill of Materials from the menu. Under Line Item Definition, enter the string of column headers in the header field. This will define the headers in the generated BOM file. Enter the string of properties into the Combined Property field. This text must precisely match the property fields added, including spaces and case. To view the BOM in Excel, check Open in Excel. Ensure the scope is set to Process Entire Design and the mode is set to Use Instances. Click OK. The bill of materials is generated and opens in Microsoft Excel. The bill of materials can also be viewed at any time under Outputs in the project hierarchy. If a component database is configured with CIS, BOM creation becomes more automated, pulling the fields, vendor, and manufacturing information directly from your component database. To generate a CIS BOM, select Reports, CIS Bill of Materials, Standard from the menu. The Standard Bill of Materials window opens. Here you can select the template to use and the properties to include. The Report Properties section shows the fields that can be configured in the Bill of Materials. Check the option to export BOM report to Excel to open the BOM report in Excel for easy sharing with stakeholders and purchasing. The structure of the CIS Bill of Materials can be saved and reapplied to future designs, expediting the BOM generation process further. To do this, enter the desired template name into the Template Name drop-down. This will save the template, which can then be selected for use in future designs. To generate the BOM, click OK. The BOM opens in Excel, showing the list of parts, their values, manufacturer name, and manufacturer part number. This completes the lesson on generating a bill of materials in OrCAD X. In this lesson, we will show you how to generate a PDF and Smart PDF of your schematic design. A Smart PDF includes a hierarchy that you can navigate through without losing your design IP. Let's generate a standard PDF first. Select the design file from the design hierarchy. Select File, Print from the menu. The print window opens. Select Setup to change the active printer. Select Microsoft Print to PDF from the name drop-down under Printer. Select Landscape for the orientation and click OK. Click OK again to start the print. The file browser opens. Browse for a location to save the PDF file. Enter a name and click Save. To view the PDF, open File Explorer and browse to the location. Open the file on a PDF viewer such as Adobe Reader. The schematic is shown in the PDF viewer. Now let's create a Smart PDF. A Smart PDF contains part information and a hierarchy to easily navigate the design. Back in Capture, select the design file. Select File, Export PDF from the menu. If this is your first time generating a Smart PDF, red text will be visible. The Ghost script interpreter needs to be installed on your machine. Click the link to open the download window. Select the appropriate link to download Ghost script. The file browser opens. Browse to a location to save the installer. Run the installer and follow the on-screen prompts to install GoScript. Back in Capture, select the ellipsis for converter path. Browse to C, Program Files, GS version, binary. Select gswin64.exe and click Open to define the executable path. GoScript has been configured and the Smart PDF can be generated. Under Output Properties, select the ellipsis for Output Directory. The file browser opens. Browse to a location to save the file and click Select Folder. Enter a name for the file into the Output PDF field. Click OK to generate the Smart PDF. The PDF opens automatically in your default PDF viewer. By default, the schematic canvas will print in light mode regardless of your canvas settings. The PDF can be printed in dark mode or legacy mode by selecting Options, Extended Preferences from the menu. Select Schematic and change the schematic print theme to the desired setting. In the PDF viewer, select a part to view its information, such as PCB footprint, reference designator, and the vendor added in an earlier lesson. To navigate the schematic, open the Bookmarks panel. Select a reference designator bookmark. The PDF will zoom into that part. This completes the PDF generation lesson. In this lesson, we will show you how to generate a netlist and layout file. A netlist is required to create a board layout. We'll start by generating just a netlist by itself. Select the design file in the Project Manager. Select Tools, Create Netlist from the menu. Under the PCB tab, select Create PCB Editor Netlist. Select the ellipsis under Options to browse for a location to save the netlist. Select the desired folder to save the netlist files and click Select Folder. If this is your first time netlisting, the configuration file must be defined. Select Setup. Select the ellipsis to load the file. Browse to the location of the Allegro configuration file. The default path is C, Cadence, SPB 25.1, Tools, Capture. Select the file and click Open. Click OK in the Setup window. Click OK to netlist the design. The 3 netlist data files are generated in the specified location. Now let's generate the netlist and PCB layout file together to streamline the PCB layout process. To configure the layout, select PCB Design Sync Setup from the menu. The Design Sync Setup window opens. Here you can configure the layout folder, placement options if the board already exists, desired software to open the layout in, and more. With OrCAD X, you have the option to select from 2 different layout environments, OrCAD X PCB, which is the classic user interface, or OrCAD X Presto, which contains a new, updated user interface for improved ease of use. For this example, we will use Presto. If you would like to continue with the walkthrough using OrCAD X PCB Editor, make sure to select it as your PCB tool. Select the tool from the Select Layout tool dropdown and click OK. To generate the layout, select PCB New Layout from the menu. The New Layout window opens. Select the ellipsis for PCB Layout folder to open the file browser. Browse for a location to save the board file and click Select Folder. Enter a name for the board file in the board field. Typically, this is the same as the project name. Leave Input Board File blank to create a new design. Click OK to create the new layout. The specified PCB tool opens. Select the required license from the Cadence Product Choices window and click OK. If the layout file does not open automatically, select File Open from the menu and browse to the Allegro folder in the working directory. Select the board file and click Open. This completes a lesson for netlisting and board generation. In this lesson, we will show you how to use LiveBOM to perform supply chain analysis on components in the schematic and ensure all parts in your design remain active throughout the design process. LiveBOM analyzes the design for potentially at-risk parts and provides replacement options to ensure that all parts in the design are up to date. Open the provided or continued design in OrCAD X Capture CIS. Make sure to launch OrCAD with a license of OrCAD X Professional to utilize the functionality covered in this lesson. Select Tools, LiveBOM from the menu to activate LiveBOM. The LiveBOM interface opens. At the top of the window, there are several categories, including the complete list of parts, parts with no matching manufacturer part number, unique parts, at-risk parts, obsolete parts, and more. Selecting a category will turn its filter on or off. Select the Tile View mode to view a tiled window of the BOM health. View the BOM health panel. This panel shows a letter grade for the design based on the number of parts matched, their availability, and their risk. The numbers of matched, unmatched, and at-risk parts are also shown. Currently, this design has a grade of D, as 3 parts are unmatched and 3 are at risk. The pie charts on the right side of the window show availability and overall design risk. For this design, the charts are mostly green, indicating a low overall risk. Scroll down to view the tables for high-risk parts, end-of-life parts, and inventory risk parts. 3 capacitors in this design are flagged as high risk and should be replaced. Let's view the list of parts in the main panel. All at-risk parts can be viewed in the risk category. Select Risk from the top to view the list of at-risk parts. Select a row for C1. Under Supply Risk in the Properties panel, the part is listed as May Not Be Available. The part is also listed as Not Recommended for new designs. The Properties panel also shows general part information, reach and roast compliance, part status, and more. LiveBOM also provides insights into supply chain forecasting. Select the Supply Chain Forecast mode to view the expected lead time, inventory change, price change, and availability of the component. The forecast period and timeline can be configured in the Forecast Options panel. Next, we'll replace this part with a better alternative. Select the Alternate Parts tab. Select an equivalent capacitor with low risk from the Alternate Parts list toward the bottom of the window. The Properties panel now shows a higher availability score and more distributors carrying the part. Since this part is not at risk of becoming unavailable, let's use it for C1. Select the plus sign for Replace MPN to replace the part number. The part and supply chain details are updated accordingly. Complete this process for the other 2 capacitors. The high-risk parts have been replaced. Now let's match the unmatched parts in this design. Select the Unmatched category from the top of the window. The unmatched parts include IC1, JP1, and Y1. The Supply Chain Details section of the table is labeled Unmatched for each part. Let's replace the crystal. Select the row for Y1. The term 8 MHz is searched automatically. A part search can be filtered for more specificity. Enter crystal 8 MHz Abracon into the search field and press Enter to search for all available crystals. Select a 4-pin crystal from the list and click Replace MPN to replace the part. Complete this process for all parts that are unmatched. Updating the parts list in LiveBOM will automatically update the list in Capture. Close the LiveBOM tab. Select the design file on the Project Manager and select File, Save from the menu. Right-click the design file and select Edit Object Properties. View the Property Editor tab. The part numbers for C1, C3, C4, and Y1 have been replaced. This completes the bonus lesson for real-time supply chain analysis with LiveBOM in the OrCAD X Capture 25.1 walkthrough. This lesson will show you how to configure workspaces and connect your project to Cloud Workspace. This will allow for easy sharing of the library and design with team members for efficient collaboration. Open the Provided or Continued Design in OrCAD X Capture CIS. Make sure to launch OrCAD with a license of OrCAD X Professional to utilize the features discussed in this lesson. To create a new workspace, select View, Workspace, Configuration from the menu. The Workspace configuration window opens. Select Cloud for the CIS data source to work with the cloud database. Select New Workspace to create a new workspace. Enter a name for your workspace into the Name field. In this example, we will call our workspace Engineering. Select the appropriate location from the Data Residency dropdown. From here, you can also define the default role for new users and whether to allow workspace access for all users or selected users in your organization. Leave the other settings as the defaults and click OK to create the workspace. Select the new workspace. Your Cadence user profile is automatically added to the members list at the bottom of the window. To add another user, enter their Cadence email account into the Add New User text field. Press Enter. Select the user role from the drop-down next to their name. Admins have complete access to all objects in a shared workspace and can perform any possible task. Designers can check in or check out a design to update and modify it. Librarians have part authoring, editing, and publishing capabilities. Users have read-only access to objects in a shared workspace. Right-click the new workspace and select Set as Default. The green checkbox moves from My Workspace to Engineering, indicating that it is now the default workspace. Click OK to save the settings and close the window. With the workspace configured, it can now be used to share libraries and design files with team members for efficient cloud-based collaboration. This lesson will show you how to share, manage, and edit design files in cloud workspaces. Managing a design in the cloud enables teams to collaborate and keeps designs up to date for all team members. Open the provided or continued design in OrCAD X Capture CIS. To create a shared workspace, advanced cloud capabilities are needed. Once a workspace is created, it can be shared with additional users who can participate and manage content in the workspace as needed, including editing and publishing designs. In the Project Manager, right-click the design file and select Add to Workspace. The project is added to your local workspace. Close the Project Manager to close the project. Let's upload this design to a cloud workspace. Select the File Manager button from the toolbar to open the File Manager tab. Under Workspaces, expand My Workspace and select Projects. The Capture Tutorial project folder is listed. Right-click the folder and select Publish. The Publish window opens. Select Engineering from the Target Workspace dropdown. Select Major for the revision to publish the first revision of the part as 1.0. Enter any desired comments under Comments. Check Delete from My Workspace to remove the project from your personal workspace. Click Publish to move the project to the Engineering workspace. Other team members can now inspect and edit the project. Expand the Engineering folder and select Projects. A new folder is listed for the Capture tutorial. Double-click the folder to open it. All project files are listed with the revision number and an unlock symbol to indicate that the project is checked in and can be edited. Now let's edit a cloud-based project. Any designer or admin can lock a project in the cloud workspace to be edited. Select the Engineering Projects folder in the File Manager. Right-click the project file and select Edit. The Edit window opens with your personal workspace automatically selected. Click OK. The project has been checked out and locked. Open the project folder. A lock symbol is now shown with your Cadence ID, indicating the checkout. A locked project cannot be edited by any other team member. Select My Workspace, Project, Capture Tutorial in the Workspace hierarchy. Double-click the project file to open the project. The completed project is opened as a normal local project and can be edited as such. Check the project in so it can be viewed and edited by other team members. Save the project file and close the Project Manager. Select the File Manager button to open the File Manager. Select Workspaces, My Workspace, Projects from the sidebar. Right-click Capture Tutorial and select Publish. Set the desired workspace, set the revision to minor, and enter any desired comments. To delete the project from your workspace, check Delete from My Workspace. Click Publish. Select the Engineering Projects Capture Tutorial folder. All project files are now shown as unlocked with the revision number incremented and comments added. This lesson is going to show you how to create and manage libraries for individual and shared workspaces. This will allow for easy sharing of parts and libraries with team members for efficient collaboration. Library parts can also be added directly from industry-leading sources for reuse of verified component symbols and data in future designs. Open the provided or continued design in OrCAD X Capture CIS. Let's start by creating a new component in the individual cloud library. Select Place Component from the menu to open the Component Explorer tab. The Component Explorer tab opens. The Categories panel on the left lists all categories from which parts can be placed in the design. Select New Component to add a new component. The Component window opens. In this example, we will model a diode after the NTE 5800 rectifier diode. Enter NTE 5800 for the part number and select Active from the Lifecycle dropdown. Select Diode from the Category drop-down. The Property tab is automatically populated with default values and the default symbol and footprint for the corresponding category. Set the reverse voltage to 50 volts, the forward voltage to 1.2 volts, the forward current to 3 amps, and the reverse leakage current to 500 microamps. Set the power dissipation to 5 watts, the maximum temperature to 125 degrees Celsius, and the minimum temperature to -65 degrees Celsius. Click Save to save the component. To view the component, expand the My Workspace folder and select Diode. The NTE5800 is listed here with all previously created diodes. Now let's publish the component to the cloud so it can be accessed by other team members. Right-click the diode row and select Publish. The Publish Part window opens. Select Engineering as the target workspace. Select Major to publish the first revision as 1.0. Add any desired comments and check Delete from My Workspace to remove the part from your local workspace. Select Publish. The part is removed from your personal workspace and moved to the engineering workspace. The part can be placed in the schematic from a cloud workspace. To do this, select the part in the workspace. Right-click and select Place. Click to place the part in the schematic, then right-click and select End Mode. Let's confirm that the properties defined in the workspace carried over to the placed part. Right-click the diode and select Edit Properties. The Property Editor tab opens, showing the parameters we assigned in the component window. Close the tab. Since we don't need this diode in the design, we can delete it. Select the diode and press Delete on the keyboard. To improve organization of your cloud-based component libraries, you can create additional categories in your workspaces. Let's create a MOSFET category. Back in the Component Explorer tab, right-click My Workspace and select Add Category. The category window opens. Enter MOSFET for the name and select Electrical for the part type. In a property table, you can define information that should be defined for any MOSFET added to your cloud library. This will create consistency in the data required for MOSFETs in your component library. Select the cell under Name and enter VDSS for the property name. Under Description, enter Maximum Drain Source Voltage. Leave the default settings for visibility on schematic and value type. Check the option for Show in Place component to show the property in the Component Explorer tab. Add the remaining properties to the table. With the properties assigned, let's add a default symbol and footprint. Select the Models tab and select Attach Symbol. The Symbols window opens with a list of predefined libraries and symbols. Select Libraries, Symbols, Templates for a list of common symbols. Check NMOS and PMOS under Symbol Name and select Attach. This will allow either symbol to be used by added MOSFET components. Select Attach Footprint. In the Footprints window, select and check the appropriate footprint. Select Attach. The footprint is attached to both symbols. Select Save. The category has been added to the list under My Workspace. Now let's create a new part using UltraLibrarian. Select UltraLibrarian in the Categories list. If prompted, log in with your UltraLibrarian username and password. Enter the desired part number into the search field and press Enter to search. In this case, we will search for the SI2347DS P-channel MOSFET. All parts with the search string in the name are listed. Right-click one of these parts and select Add to Library to download it. The component window opens. Check any parameters with no value or description defined, then click Delete to remove them from the list. Select MOSFET from the Category dropdown and Active from the Lifecycle dropdown. The MOSFET parameters previously defined are added to the property list. Set the drain source voltage to 30 volts, the drain current to 5 amps, and the on-state resistance to 42 milliohms. Set the threshold voltage to 2.5 volts, the gate charge to 220 nanocoulombs, and the maximum gate voltage to 20 volts. Set the input capacitance to 705 picofarads, and the maximum power to 1.7 watts. To set the symbol and footprint, select the Models tab. The previously defined symbols and footprints are listed, along with a new symbol and footprint downloaded from UltraLibrarian. Since this is a surface mount P-channel MOSFET, we don't need the through-hole footprint or N-channel symbol. Right-click NMOS and select Remove Symbol Association to remove the N-channel symbol. To remove the footprint, select Attach Footprint. Uncheck the option for TO220AB to remove the through-hole footprint. Click Attach. The primary footprint is now the SOT23 footprint downloaded from UltraLibrarian. Click Save to save the component to your workspace. To view the saved part, select the MOSFET category under My Workspace. The part is shown with the defined properties and its symbol and footprint. In this lesson, we will show you how to embed comment and markup for design review in a schematic file. OrCAD X Capture 25.1 includes the ability to add comments to a schematic file for efficient design review and collaboration. Open the provided or continued design in OrCAD X Capture. Select Tools, Markup from the menu to open the Comments panel. In the Comments panel, select New Comment. Zoom into the desired section of the board and enter the desired text into the comment bar. To highlight the relevant area, select Draw Rectangle. Click to begin drawing the rectangle. Move the mouse to draw the rectangle over the area of interest on the schematic and click to finish the rectangle. Click Submit to publish the comment. The comment has been numbered and embedded into the design database, making it accessible for any users to review. Once you receive a design with embedded comments and markup, you can use Capture to review the feedback. Since comments and markups are embedded in the design files, designs can be shared through manual methods such as shared folders or email, or integrated methods such as Cloud Workspaces or OrCAD EDM. Open the design file to review in OrCAD X. Select Tools, Markup from the menu to open the Comments panel. Click a comment to be brought to its location in the schematic canvas. Click the PCB icon to view a snapshot of the schematic when the comment was recorded. To respond to the comment, enter the desired reply into the Mention or Comment box. Click Submit when finished. To resolve a comment, click the ellipsis at the top of the comment and select Resolve. You can also edit or delete comments from this menu. When finished, select the comment icon to turn off visibility of the comments in the PCB canvas. Repeat this process as needed to efficiently communicate with team members and perform design reviews using OrCAD X Capture. This concludes the OrCAD X Capture 25.1 walkthrough. This Capture walkthrough is a brief overview of the capabilities in OrCAD X Capture 25.1. EMA Design Automation offers full training options for self-paced learning, online instructor-led classes, and training in a classroom setting. To continue with the OrCAD X walkthrough series, select the next walkthrough series based on your desired PCB tool, OrCAD X PCB Editor or OrCAD X Presto. OrCAD X PCB Editor provides a feature-rich environment to create a board layout with an assortment of tools including delay tuning, glossing, real-time routing feedback, workflows, and more. OrCAD X Presto provides a user-friendly interface with the same powerful Allegro features to improve efficiency and streamline your PCB design process. Find all of our training options at EMA Academy.